In this particular problem, we're looking at a brand of light bulb that has a mean life of 600 hours and a standard deviation of 53 hours. In the very first part of the question, we're told that the histogram of the data indicates that this is a bell-shaped distribution, okay? Bell-shaped. So that means, let me see if I can make a little sketch here. It looks a little something like this. Okay. And with this distribution, it's going to follow the empirical rule. Now, the empirical rule is given as 68, 95, 99.7. So as we look at the mean, that's going to be here at the center of this distribution. That's the average lifetime of these light bulbs is 600. So I'm going to go ahead and label that as 600. And the standard deviation is 53. Now, most of your data is going to occur within 3 standard deviations of the mean. So I'm just going to go out and mark out 3 places to the right. 1, 2, 3 here on the side, and 1, 2, 3 to the left. So the distance from the mean to the first standard deviation, or the value here, the end of that, is going to be 600 plus 53. So that is 653. And I'm going to try to squeeze that in here. I don't know how good it'll be, but anyway, 653. If I go 53 more, then this value is going to be sitting at 706. And 53 more, this value is 759. And then I want to go 1 standard deviation to the left, so that's 53. So 600 subtract 53, that means this point's sitting at 547. And 1 more standard deviation to the left, this point's going to be at 494. And 1 more standard deviation to the left puts this point at 441. Now, going back to the 68, 95, 99.7 rule, what that says is that within 1 standard deviation of the mean, so that means 1 standard deviation to the right and to the left, we're looking at this area under the curve. That area is going to be 68%. So 68% of the data falls between 547 and 653. Within 2 standard deviations, okay, so if I start here, 2 standard deviations to the left, and go all the way over here, 2 standard deviations to the right, there. This area under the curve, all of this, is 95%. So in the pink, that's the 95%. And then the 99.7, with that, we're looking at 3 standard deviations from the mean. So everything from 441 all the way out here to 759, all of this area under the curve, this is 99.7%. That's in the yellow. So understanding the layout of the bell-shaped curve and these three amounts that are listed here for the empirical rule, we're going to answer our questions. So the first question says 99.7% of light bulbs have lifetimes between. So that's the three standard deviations. So that's going to start at the 441 and end at the 759. What percentage of light bulbs will have a life between 494 and 706? So we're looking at this area. That was the pink one I did earlier. 706, and that's 95%. Assuming the data is bell-shaped, what percentage of light bulbs will last between 547 and 706? Now, so that's one standard deviation to the left, but two to the right. So what we do know is that this little piece right here, from 547 to 653, that is 68%. And the nice thing about a bell-shaped curve is that it's symmetric. Gracious. So let me go back and re-sketch it down here at the bottom. Let's start to be on top of things. Oops. Me. Sorry. I think I might need to install a driver or something. Okay. Gracious. Might need to install a user. Okay. So this is my mean. This was one standard deviation to the left. And then we're going to go out two standard deviations to the right. Gracious. So because this curve is symmetric, I'm going to go ahead and put these other little divisions in here. Gracious. So this ends up being half of 68. So this is 34%. Sorry. So this is 34%. And this is 34% for our area right here. And then this little piece right here is we've got to subtract 68 from 95, and that gives us these two blocks, and then divide it by 2. So 95 subtract 68. That difference is get it right. And then divide that by 2. So each piece here is 13.5. So once I divide that by 2, so now I can add 34 plus 34 plus 13.5, and that's where we get the 81.5%. And then the last question says, if the company that manufactures the light bulbs guarantee to replace any bulb that does not last at least 441 hours, well, remember that was the one that was way out here at 3 standard deviations to the left, the 441. So I'd have to take 99.7% from 100, so that's 0.3%, and then divide that by 2. So 0.3 divided by 2, this little block area right here is going to be 0.15%. So that's where we get this answer of 0.15%. I hope this helps.